This is the Unit 3 practice test found on page 223 of your book. There's 25 problems on the practice test, and your actual test will look very much like this practice test. Alright, so problem number 1 is to find the greatest common factor of these two terms. So recall that when we find the greatest common factor, we look at the variables that are the same, and the GCF can only be what they have in common. So it's going to be whatever the smaller exponent is. So if we look at the a and the a to the fourth, the GCF will be a. Alrighty, I'm running into problems. The GCF of a and a to the fourth is a. The GCF of b squared and b squared would be b squared. And the GCF of c to the fourth and c would be c. So they can only have in common whatever the smaller exponent is. So the greatest common factor is a b squared c. Now from here on out, we're not just stating what the greatest common factor is, we're factoring out the GCF. So we have to write our answer as the product of the GCF and some other factor that we will get from dividing the polynomial by the GCF. Okay, that was a lot to say. So anyways, let's look at the first binomial. We have 9a squared b cubed minus 18b squared. First of all, let's find the greatest common factor of each of these two terms. So the greatest common factor of this and this, 9 and 18, is 9. Notice a can't be part of the GCF because both terms don't have a. The greatest common factor of b cubed and b squared is b squared. So that's what we're factoring out or pulling out of those two terms. So we're kind of like undoing distribution. So when we distribute, we multiply. So since we're undoing that, we're pulling it out. So we're going to have to divide. So we're going to divide each of these terms by 9b squared. We can remove those common factors. Remember that when we divide with those common bases, we subtract our exponents, so we get a squared b minus 2. So we get 9b squared multiplied by a squared b minus 2. And if you want to check your answer, you can remultiply that. We're just factoring out the GCF of this trinomial. The greatest common factor of 9, 36, and 9 is 9. And each of the terms has a y. We have a y cubed, a y squared, and a y, so we can factor out a y. That will go away. Y cubed divided by y is y squared, minus 36y squared divided by 9y is 4y, plus 9y divided by itself is 1. Don't be tempted to leave that as 0, okay? 9y divided by 9y is 1. And since it just says factor out the GCF, I'm not going to bother to try to factor that trinomial. I believe it's going to factor. Alright, now this is taking us into factoring by grouping. Number 4 just says factor. We have x times a plus b, and we have 5 times a plus b. Common factor a plus b. We're pulling it out. If I pull out that a plus b, I'm undistributing, so I have to divide each term by a plus b. So my missing factor is x plus 5. I could also write that as x plus 5 times a plus b because of the commutative property allows me to do that. Now notice we have 4 terms in the next polynomial. X squared y, 8x squared, 3y, and 24. And whenever our polynomial has 4 terms, we factor by grouping. So I'm going to group this, and I'm going to factor the greatest common factor out of there. The greatest common factor of these two terms is x squared. So I'm going to divide each of these by x squared. I can remove those factors. I get y plus 8. Okay, and you're probably going to want a y plus 8 over on this side, but you can see you're factoring out, you can factor out a positive 3. on this side, a positive 3. 3y divided by 3 is y. Positive 24 divided by positive 3 is positive 8. X squared times y plus 8, 3 times y plus 8. Factor out a y plus 8. Pull it out, undistribute. Divide by y plus 8. Divide by y plus 8. Remove those factors to find your missing term, x squared plus 3. Or you could write that as x squared plus 3 multiplied by y plus 8. All right, moving right along. All right, factoring by grouping in each of these as well. 4a squared plus 5ab, I can factor an a out of there. So I'll divide each of these by a. 4a squared divided by a is 4a plus 5b. Now notice these next two terms, negative 10b and negative 8a, are both negative. You want them both to become positive, which means you're going to factor out a negative. So notice the greatest common factor here is going to be a negative 2. You're factoring out a negative 2. Negative 10b divided by negative 2 is positive 5b. Negative 8a divided by negative 2 is positive 4a. Now 4a plus 5b is the same as 5b plus 4a. So this term has a common factor. That these two terms, a and 4a plus 5b, negative 2 times 5b plus 4a, have a common factor, 4a plus 5b, that I'm going to factor out now. And I'll divide each of these by 4a plus 5b. And I'm left with an a minus 2. So 4a plus 5b multiplied by a minus 2, or a minus 2 multiplied by 4a plus 5b. Alright, this is our last factoring by grouping. So let's factor an x squared out of these first two terms. Divide by x squared on each of those, and I'm left with x plus 4. I will factor out of here and here a positive 6. Left with x plus 4. Now I will factor out of here and here. I'm pulling out an x plus 4. I will divide each side by x plus 4, undoing that distribution. And I am left with x squared plus 6. So I have x plus 4 multiplied by x squared plus 6. Or you can write it the other way. Alright, now it's time to multiply or to factor some trinomials. Alright, recall when we factor trinomials, well, we're unfoiling, okay? This is positive, so my signs will be the same down here. It's my f. X times x is x squared. Then I look at my L, factors of 8. 1 and 8, or 2 and 4, but I'm looking for the 2 that will add up to 6x. So I'm going to choose 2 and 4. 2 times x is 2x. X times 4 is 4x. I need a positive 6x. So both positive. So I have x plus 2 multiplied by x plus 4. Or you could write x plus 4 multiplied by x plus 2. Y squared minus 8y plus 15, both of my signs will be the same once again because that's positive. Notice these two trinomials, I have a leading coefficient of 1. This was section 3.3. Y multiplied by y is y squared. Now I will look at my L. That came I'm talking about FOIL. When I multiplied my last times last, that's my 15. That's factors of 15. 1 and 15, or 3 and 5. I'm looking for my 2 that will give me a negative 8, and that would be 3 and 5. 3 times y is 3y. Y times 5 is 5y. To get a negative 8y, they must both be negative. So I have y minus 3 multiplied by y minus 5, or y minus 5 multiplied by y minus 3. All right. This is negative, so my signs are different. Now you may look at 117 and think, what numbers will go into there? What I did was, first I said, oh, well, 2's not going to go into there, so it's not an even number. When I'm checking to see if 3 or 9 will go into a number, you might recall that if you add the digits, like 117, 7 plus 1 plus 1 is 9. And 3 will go into 9 evenly, and so will 9. So that's what I looked at to find some factors of 117. So I divided 3 into 117 to see if those two factors would work. And then I divided 9 into 117. So I know my signs have to be different because this is negative, the sign in front of the 117. So I know z times z is z squared. So I divided 9 into 117. I knew it would go because 7, 1 and 1 is 9, and 9 will go into 9. We'll divide into 9 evenly. Okay. So for 117, 9 times 13. Your signs are different, and 13 minus 9 is 4. Thirteen times z is 13z. Z times 9 is 9z. I'm looking for negative 4z. So to get negative 4z, the 13 would have to be positive, and the 9 would have to, or the 13 would have to be negative, excuse me, and the 4 would have, or the 9 would have to be positive. You can always use FOIL to check your answer. We get z minus 13 times z plus 9. Alright, this is positive, so my signs will be the same here. Notice now I have a leading coefficient greater than 1. I have a 2y squared. So my f has to be factors of 2. Well, there's only two factors of 2, 1 and 2. So I have 2y times 1y. My L is also factors of 2, which are 1 and 2. So I believe my 2 will have to go here and my 1 will have to go here. I'll check my inner and outer. They need to add up to 5y. 1 times y is 1y. 2y times 2 is 4y. It has to add up to positive 5y, which it will as long as everything's positive. So we get 2y plus 1 multiplied by y plus 2. Signs will be the same in my binomials because that's positive. Factors of 6, 1 and 6, or 2 and 3. I will start with 2 and 3 since they're closer together. So 3x times 2x. Factors of 12, 1 and 12, 2 and 6, or 3 and 4. And I will start with 3 and 4. Obviously I can't put the 3 with the 3, which means the 4 would have to go here and the 3 would have to go here. And let's check this out to see if it works. 4 times 2x is 8x. 3x times 3 is 9x. And we're looking for a negative 17x, the O and the I. And my signs are the same as long as they're both negative. That works out. 3x minus 4 times 2x minus 3. My signs need to be different here. Factors of 9, 1 and 9, and 3 and 3. And then my L, notice, guys, are 1 and 3. Now think about this. If I choose my f to be 3 and 3, I'm going to put a 3x here and a 3x here. Now, if I choose my L, it'll be 1 and 3. I cannot put a 3 here or a 3 here, which means I can't use this. I'm going to have to choose a 1 and a 9. So let me go back here and get my eraser. This can't be right. Get my felt tip pen. It's going to have to be a 9x times 1x. Now I'll go back, and now I'll go ahead and choose my 1 and 3. I can't put the 3 with the 9, which means I'm going to have to put the 3 here and the 1 here. Now I'll check my inner and outer. 1 times x is 1x. 9x times 3 is 27x. It needs to add up to negative 26x. This is negative, this is positive. 9x times negative 3, positive 1. So we had 9x plus 1 times x minus 3. That was a good little problem. All right, they're getting a little easier now. These are both difference of squares, right? These aren't trinomials because your outer and your inner add up to 0. So really, this was, when you started out with your two binomials, your f came from here, and this was your L. There was no outer or inner because when you added those together, they added up to 0. A times A was A squared. 8 times 8 was 64. 1 was a plus, 1 was a minus. A plus 8 times A minus 8, or A minus 8 times A plus 8. Because notice, look at 8 times A is 8A. A times negative 8 is negative 8A. That added up to 0. That's why there's no middle term once I said up above. Same thing here. The square root of 64z squared is 8z. We'll be talking about square roots in the next unit. The square root of y squared is y. 1 plus 1 minus. Now these were also special products. They're trinomials, but look at your first and third terms. Perfect squares. 2a multiplied by 2a is 4a squared. 3 multiplied by 3 is 9. Now you should check your inner and outer. This produces 6a. Your outer produces another 6a, which adds up to 12a. You need a negative 12a. So these should both be negative. And a better way to write your answer would be to write 2a minus 3 squared. And I believe the next one is also a perfect square trinomial. This is a perfect square. This is a perfect square. You just need to check your outer and inner and make sure it adds up to 16y. Notice your signs are the same. That would also have to be the case. Y times y is y squared. 8 times 8 is 64. 8y and 8y is positive 16y. So we'll write our answer as y plus 8 raised to the second. Notice number 18, it says factor if possible. That's your clue, guys. This is a sum of squares. Look for a greatest common factor. There is no greatest common factor of x squared and 4. This is a sum of squares. This is not a difference of squares. As you recall, this is non-factorable or prime. Okay? Now I believe all the rest of them, all the ones where we're factoring, say factor completely. That's your clue that you may need to do more than one thing. Look for a GCF first. Factor out a GCF first. And you'll notice here, I believe you can factor an 8 out first. And this is a trinomial, so we'll probably factor out a GCF and then need to factor the trinomial. We can remove the 8s. We'll have a squared plus a minus 6. Our signs will be different. A times a is a squared. Factors of 6. 1 and 6, 2 and 3. It needs to add up to positive 1. So 3 and 2. 3a. 2 times a is 2a. To get a positive 1a, this is negative, this is positive. So we have 8 multiplied by a plus 3 multiplied by a minus 2. Or you can have 8 multiplied by a minus 2 multiplied by a plus 3. Don't forget to put the 8 in your answer. Factor completely. It looks like you'll only have 2 factor completely, so that won't be so bad on the test. Alright, so the greatest common factor here, we can factor out, it looks like 7, 21, and 14 have a GCF of 7. However, notice we have an a cubed, an a squared, and an a, so we can also factor out an a. So the greatest common factor is 7a. Which will leave us with a squared plus 3a plus 2. Now we'll factor the trinomial. Notice both signs will be the same. A times a is a squared. Factors of 2 are 2 and 1. 2 times a is 2a. A times 1 is 1a. Great. It adds up to 3a. And my a doesn't want to write down there. Both positive. So we have 7a multiplied by a plus 2 multiplied by a plus 1. Must be too close to the bottom. Alright, now the next one, number 21 and 22 and 23, we're solving. Okay, these are quadratic equations. Now 21 says z plus 5 multiplied by z minus 9 equals 0. So we're using that zero product rule. If two things multiplied together are equal to 0, then one of them must equal 0. This must mean that either z plus 5 is equal to 0 or z minus 9 is equal to 0. So here we just solve each of these linear equations. We would subtract 5 from each side here. So that means z equals negative 5. Or here we would add 9 to both sides, which means z will equal 9. So those are the two solutions. Negative 5, 9. Those are the two values that make the equation true. Now, number 22, before you can solve the equation, notice it's in standard form. Z squared plus 5z minus 14 equals 0, which it needs to be first, but we need to factor it first. The previous one was already factored. So we need to factor this left-hand side. So that it looks like the previous one. So we know that z multiplied by z equals z squared. I know my signs will be different. My factors of 14 are 1 and 14, or 2 and 7. 7 times 2 is 14. It needs to add up to positive 5z. 7 times z is 7z. Z times 2 is 2z. So I need a negative 2 and a positive 7. Z plus 7 times z minus 2 equals 0, which means either z plus 7 has to equal 0, or I'm running out of room, or z minus 2 has to equal 0. Well, if z plus 7 equals 0, I'll subtract 7 on each side. That means z equals negative 7. I'm going to my things aren't working exactly right here, but I guess I'll keep going. If z minus 2 is equal to 0, I add 2 to both sides, and z will equal 2. Boy. Okay. So my solutions to number 22, z equals 2, negative 7. I don't want to have to start over at this point, so I hope I don't have any major issues and have to stop at this point. Okay. Now this next problem, number 23, it's not in standard form, so I need to move everything to the left-hand side before I can factor it. So this negative 9 needs to move to the left, so I need to add 9 to both sides to move it to the other side. So then I'll have 3t squared minus 28t plus 9 equals 0. Then I can factor it. So factors of 3 are just 3 and 1, 3t times 1t. My factors of 9, 1 and 9 and 3 and 3. And you can see 3 and 3 aren't going to work because I can't put a 3 with a 3. So it's 9 and 1. And I can't put the 9 with the 3 either. So the 1 will have to go here and the 9 will have to go here. So 1 times t is 1t, checking my inner. 3 times 9 is 27. Both of my signs are the same, and it needs to add up to negative 28, so both of my signs will have to be negative. So both of these factors multiplied together equals 0. So one of them, we need to set each of them equal to 0 and then solve each of them. So if 3t minus 1 equals 0, if I add 1 to both sides, divide by 3, and you'll see t equals 1/3. If t minus 9, I'll add 9 to both sides, and t will equal 9. So t equals 1/3 or 9. Those are the two solutions. Right, 2 more problems. The last topic that we covered in Unit 3, we simplified rational expressions. And rational expressions are just fractions that have numerators and denominators that are polynomials. And before you can simplify these or reduce them, you need to factor them first. You can't just start canceling out terms. Okay? For instance, look at this first 124. You couldn't just start crossing out things. You can't cross out the x squareds and the x's. You have to factor them first. And then you can remove common factors. So let's go ahead and factor these two trinomials in this first fraction that we have, this first rational expression. So for this first one, if I factored this, trying to decide if I should do it right next door to it or below it. I guess I'll do it below it. I'm factoring the x squared plus 5x plus 6. I know x times x is x squared. Factors of 6 that will add up to 5x are 2 and 3. Both of my signs need to be the same, and since they have to add up to positive 5x, they'll both be positive. Now I'll factor x squared plus 8x plus 15. X times x is x squared. Factors of 15 that will add up to 8x, both of my signs are the same. I know that 5 times 3 is 15, and 5 plus 3 will add up to 8. Okay, so and it needs to add up to positive 8, so both of these will be positive. X plus 3 divided by x plus 3 is 1. So simplified, I have x plus 2 over x plus 5. You're done. Do not cross out those x's. It's x plus 2 factor over x plus 5. Alright, notice in the numerator on the next one I have a difference of squares 9 minus y squared. You do not have to rewrite that in descending order, okay? Just factor it. If you factor that, this is your f. Don't put it in the L position. 3 times 3 is 9. Y multiplied by y is y squared. Y squared. Need to slow down. One's a plus, one's a minus. Factoring this, y multiplied by y. My signs are different. Factors of 15, 5, and 3. It needs to add up to a negative 2y. So my 5 needs to be negative because it's larger. Negative 5y, my outer positive 3y will give me a negative 2y. Okay. Now I need to remember, if you have a common factor on the numerator and denominator, you can remove it. And notice 3 plus y is equal to y plus 3. So this divided by this is 1. So you're left with 3 minus y over y minus 5. Right, and that concludes the review for the Unit 3 practice test.